Recorded at the Mandito Amplification Annex of Maggio Music Center in Brooklyn, New York. Today at the Mandito Amplification Annex of Maggio Music Center in Brooklyn, New York, we have a 1997 Marshall JCM 900 50-watt high-gain dual reverb guitar amplifier head. This is the 4500 model. Over at the store, Mike Maggio already took this unit apart and determined that the amplifier requires more than just a quick fix, so that's why all the knobs have already been removed. This amplifier is equipped with two ECC83 or 12AX7 preamp tubes, one ECC83 or 12AX7 phase splitter tube, and two 5881 power tubes. Yes, this is one of the 5881 power tube equipped Marshall amplifiers. At the time that this unit was built, new production EL34 power tubes were in short supply, so they used 5881 tubes in their place. The customer complaint is poor quality tone and low power output. This amplifier is owned by a rehearsal studio, so what exactly happened is unknown. The Marshall JCM 900 platform was first introduced in 1990. So there are a lot of different variations of the JCM 900 platform. So this is the 1997 dual reverb 50-watt model with 5881 power tubes. So I haven't found the exact schematic diagram for this amplifier yet. But before I even get that far, I'm going to just look it over and figure out what's missing and see if I could figure out what exactly is wrong. I've had this amplifier in front of me some months back, and we quickly went over it, and it seems to work, but it has very low volume output. So I remember testing all of the plate voltages on the tubes, and it seemed like everything was getting the proper amount of power. So I don't think it's a transformer or wiring on that part of the circuit. But this was the first platform that has operational amplifiers in the circuit. It has clipping diodes. It actually has little LEDs in there. I don't know if a lot of the amplifier guys are going to be like, of course it does, but for the regular person, yes, they use LEDs as clipping diodes to make distortion sound. So that's kind of cool. I'll show that to you guys later. So as you can see, all the knobs are already taken off by Mike Maggio. And let's see the back here. Already got the back panel off, and the tubes are taken out. Preamp tubes are here. Reverb is unplugged, and it's kind of dirty. So I am definitely going to clean this up a little bit, and I'm going to get the 5881 tubes out. I got a nice matched set here, and then we'll come back and we'll give you my initial impressions. Without even disassembling it, the first thing that I will tell you is that it has the original power supply filter capacitors, filter reservoir capacitors. So this amp hasn't been started up in a long time. I might put it on the Variac and bring it up to voltage really slowly just to see if I could not just turn these capacitors right on, because you never know. I've seen these things in 30-year-old amplifiers that are just perfect, and then I've also had to replace them. So we will see. But from what I recall, it's not blowing fuses, and it's also not making any terrible noises. So those capacitors could still be good. But if this were for someone who was using it in a performance, if it was my own amplifier, I would just go ahead and replace those and put some, nice F&T capacitors in there. But this is for a rehearsal studio, and I'm sure they're going to want to spend the least amount of money just to get this back into the studio so that someone else can treat it badly and damage it. So that's where this thing lives. It's abused, not appreciated, but while it's here, we are going to take good care of it and appreciate it. I have a brand new match set of JJ 5881 tubes, Apex matched. I reinstalled this nut so that I can put a speaker jack in there without damaging anything. And what I plan on doing here is I am going to put these 5881 tubes in the amp. I'm going to plug it in, and I'm going to put it on my Variac, which is a variable voltage device. And I am going to start off, very low voltage and then bring it up slowly. And, with the speaker plugged in and the tubes in the sockets. And I'm going to allow the amplifier to slowly come up to power, and then hopefully those capacitors will be okay. And then from there, I'm going to sound test it before I even open it up, and let's see what happens. And another thing that I'm going to do is that I'm pretty certain that these work perfectly. I mean, there's always a chance, but they were actually a match set that were tested, so we're going to trust the company that I bought these from. But what I am going to do is I am going to, one at a time, if I determine that it isn't working properly, I'm going to start out by replacing each preamp tube, which is going to be a 12AX7, and then see what happens from there. And we'll do all this, after we start it up slowly on the Variac, and before we take the whole thing apart and really dive into it. I have the speakers plugged in, I have the power plugged in, and I have just the power switch on. So I am going to switch on this Variac, and we're going to bring this amplifier up to voltage very slowly and just on the standby. And let's see if these tubes the heater circuits start to glow, and we don't want those blue filter capacitors to get a spike in voltage and then when they're not ready and possibly just die on us, or even worse. Alright, we're on 0 volts. I'm going to bring it up to 13 volts. Nothing's happened. 26 volts. No sign of carnage yet. That's good. Alright, we're up to 39 volts. I'm just reading what's on the dial. These are not just random numbers that I'm calling out or choosing. Slowly bring it up to 52 volts. Now, I don't have a light bulb limiter. Some guys say that you should have a light bulb current limiter, and then you can figure out real quick that you got a problem. This Variac's got a really low amperage fuse in it, so it saved me before by blowing the fuse on the Variac before anything else happened. Alright, I don't see anything happening yet. Bring it up to 65 volts. I see the filament heaters on the preamp tubes glowing. I don't see the 5881s glowing yet. Let's touch them. Well, they're a tiny bit warm. These are definitely glowing a little bit. Sorry about the creaky floor in this 105-year-old building. I don't think we're blowing up. 78 volts. I think I see the heater filaments on the 5881s glowing a little bit. Alright, bring it up to 96 volts. Alright, the filaments on the preamp tubes are glowing brightly. I see a little hint of something glowing on the 5881s. I'm going to bring it all the way up to 120 volts. Okay. No carnage, no smoke, no smells, no sounds. Nothing is blown up on us. So what I'm going to do is I am going to pause the video and I am going to let the amp sit here for a little while on standby, on full voltage. Just let the tubes warm up for a few minutes, and then I'm going to pull down the voltage all the way, shut off the Variac, and then I'm going to turn the standby on and the amp power on, and then I'm going to bring the amp up slowly on the Variac with everything on, and then we'll see what happens. Okay, now the Variac is back down on 0 and it is off. The amplifier power is on and the standby is on. The tubes did get a little bit warm, but those 5881 tubes didn't really get hot like I thought they should have, so that's kind of strange. So we're gonna power on the Variac. I've got all of the knobs set on about halfway, and I have a jack plugged in. So we're going to bring it up. We're on 13 volts, 26 volts, sorry, that's what it says on here. 39 volts. Don't see anything happening yet. All right, 52 volts. 65 volts. I see the tubes heater glowing a little bit. Don't hear anything. Whoa. So the amp is working. And it's working. That's pretty loud for 65 volts AC going into it on the Variac, and all the knobs set at about 12. I mean, I don't know, I don't have any knobs on there, I just have raw naked potentiometers. But you know, I have a feeling that the last time we tested this amp, the power tubes were just bad and we didn't stick another set in there. I don't know. But, alright, well, let's 65 volts, 78 volts. It's got a little hum. Like 120 cycle hum, 60 cycle, 120. One of them. Oh yeah. I don't know what that hum is, but that might be something I need to fix. Okay, so I brought it up to full voltage. The amp is pretty loud. It's got a little bit of a hum. All right, let me unplug. Yeah. Oh, that could just be the reverb unplugged. No, that's possible. Yeah. But, it's not terrible, but it seems to kind of work. So, from here, I'm gonna pause the video and then turn the amplifier around, plug a guitar into it, and then let's see if this thing works. Okay, this amplifier is on. and there is a definite hum. So first I need to see if the if the rehearsal studio actually even cares about the hum. But I think we're going to have to consider changing those filter reservoir capacitors. But we're going to try this quickly with the guitar and see if this actually works and has some output. So, this is a circa 1990 amplifier, so I thought that I would bring out my 1991 Ibanez RG560 as a contemporaneous piece that these two guys probably would have worked together when this amp was new. Alright, we've got the guitar plugged in. Well, it doesn't sound spectacular. Just give us a little bit of volume. Oh, okay. Well, something is definitely wrong. Now, first of all, the amp is on the floor because gravity dictates that you can fall no further than the floor. So, I don't want to break anything, or myself. So that's why the amp is on the floor. Secondly, you're looking straight at it. It's in front of both of us. I know it's pissing off some of you. Right, I stuck antique style MXR style knobs on the amp for now because I had no knobs. This was brought to me with 0 knobs. I could only find 2 Marshall knobs in the stash, so those are the style knobs that I usually use on my amplifiers. Now that we've gotten past that, the elephant in the room is that this sounds absolutely awful. So okay, I think that there is very obviously something extremely wrong with this amplifier. But it's already working better than the last time I had it in front of me. So now, the next obvious step is to, one at a time, change those preamp tubes. And we're also going to need to consider changing those filter capacitors, yes, to get rid of that hum. But I mean, honestly, I should just change all the preamp tubes and not even think about it. But I'm not the kind of person that's just going to throw parts at something without at least taking the time to diagnose it step by step. So we are going to, one at a time now, change the preamp tubes and see if that improves our situation. Because right now, that sounds pretty horrendous. And I'm also, now that I know that the reverb works, I'm turning the reverb off because I'm not really a big fan of reverb. It just pisses me off. I don't like it. And especially solid state reverb. At least the old style tube reverbs had some character to it. This thing is just, it's just... Anyway, so now we are going to attack the preamp section and start changing preamp tubes. Okay, I swapped a new JJ-ECC83 into the phase inverter position. Phase splitter. I think phase inverter is a misnomer if you understand how all this works, but whatever. That's what they call it. That did not make any difference whatsoever. So we're going to move on to the second tube in the middle there. Okay, second tube. No, that's not any better either. And I don't know, it's not feeling like tubes, but just for good measure, we're going to try the first stage. And then we're probably going to end up having to open this up and then do a real in-depth diagnosis. We need to open it up anyway, even got to bias the power tubes, but if the thing doesn't work, and then we have to ask the customer if they want to pay for the in-depth diagnostic time that it's going to require to actually figure this out, that may just end the whole project right there. So let's try that first tube. I have now replaced all 3 preamp tubes, and very obviously did not solve the problem. So now I'm going to put the original preamp tubes back in, and then I'm going to disassemble the whole thing, and then now we might actually move to the bench with just the amplifier chassis out of the head cabinet. But maybe I'll stay on the floor because, like I said before, it's heavy and I don't want to drop this on myself or whatever. But we'll see. So these are the old original Marshall tubes, Marshall branded tubes. We all know that Marshall doesn't actually make tubes, but anyway. They're kind of blackened on the inside the glass, on the bottom by the pins. And, I mean, that's a sign of a lot of hours, some heat. So, I'm gonna leave these out. I'm gonna put the JJs back in and leave them there while I'm diagnosing things. So that way I have all new tubes and I'll eliminate that variable, because whatever's causing that horrible, nasty, breakup, spitting, tinny sound that I was getting and farting, I want to have the best possible chance of getting the amp to sound right without having to worry that these also sound like crap. So we might end up putting these back into the amplifier later if the customer doesn't really want to spend a whole lot of money, even though I wouldn't recommend that. But for now, we're putting these in the box, and then we're going to put them in the coffee can that you hold all the parts in. I hold all the parts in. And then I'm going to continue in the morning, and I'm going to be drinking lots of coffee, incidentally. I have the chassis out of the cabinet, and before I start testing all the voltages, I decided that I was going to, because it was mostly unscrewed anyway, just flip over this rear board, and there's, I don't know, there's lines of something. It looks kind of salty all over the bottom of this board. And there's no evidence of anything being spilled in here or anything, but that's kind of weird. So I'm going to clean that up. Never seen that before. Kind of strange. This is the front board on this JCM 900. And I'm checking with Mike Maggio. I'm Mike Mendito, so don't get confused by two different mics. Here, there's some residue on, this is a full bridge rectifier, and over this here is also a full bridge rectifier. I don't know if these are contained in like a can with some sort of a gel or liquid that will leak out. But this also looks like it's got some residue, so I had to ask him that if he tried to reflow anything, and that might be some rosin from the solder. I just don't know. And also, this board has got some powdery white residue on it as well. I don't know what that's from, if he did anything, because this was taken apart. And we had both looked at this before, and this is just kind of a problem child, this amp. So I have it here in the intensive care unit, where I could spend very long days and nights trying to figure this out. This is going to be a challenge, because there's a lot that can go wrong on this. Well, not that much. It's just not just a plain regular tube amp. It's got op amps and a low voltage power supply over here. So, yeah, it's a modern amp. Or one of the first. So this is what you gotta deal with. But it's not quite as straightforward and large form factor as a tube amp, or a tube-only circuitry amplifier. I had to move to the workbench where I can work like a civilized person and not be crawling on the floor anymore. But I think all of the picking up and tossing around the chassis is done for the moment. So I cleaned. This is not plugged in right now, so don't. And the capacitors are discharged. See, okay. I cleaned both of these boards with 99% isopropyl alcohol. I dried them with compressed air, and now I have to sit here and trace down the voltages in various spots on the circuit. Got our schematic diagram here, and I think I'm gonna go grab a bite to eat too before I really get into this. As promised, we are back on the bench with the 1997 Marshall JCM 900 amplifier, and also as promised, we've got our coffee. We need to figure out exactly what is wrong with this amp without just throwing parts at it and guessing, because we don't do that here. So the first thing, now that I've got everything back together, I'm going to tighten this last screw. I just wanted to point out that this is a number 4 by 1/4 inch machine screw. So if you lose these and you need to figure out what that is, number 4 by 1/4 inch machine screw. Anyway, we're going to figure out through further methodical diagnosis, and that involves, we're going to put one of the nuts back here on the send, and we're going to plug just a regular instrument cable into the send, and we're going to send out the signal to another amplifier that we know works properly. And that will tell us if the preamp section is functioning properly on this amp. And it will also mute the output section, so we don't have to worry about that right now. So that's what we're going to do next. Before I continue on to the next step of plugging the send here into a different amplifier to test to see if the preamp works properly, this is the effects loop. This is the send and this is the return right here. So when you plug a jack in, these are make and break cliff jacks. When you plug into here, you can see the contacts pop up and down. A common problem that people have with these amps is that there can be some oxidation, and this actually mutes and completes the circuit from the preamp to the power amp section. So if you want to, as a diagnostic step, you can loop them together with a patch cable, or you can just plug them in and out there. There are steps where you could take where you can spray some contact cleaner and maybe get a thin piece of paper underneath there and drag it in and out. While you have the amplifier on, you can also take a wooden chopstick, use a wooden chopstick, something non-conductive. That's very important. Don't go sticking something conductive into an amplifier that can have upwards of 450 to 500 volts in it. And you're going to take that while the amplifier is on, which is not at the moment, and you are going to just tap around and see if that makes any difference in the sound. Okay, now I've already done this step, so in the interest of not making a 3-hour long video, that was not the problem. But this is something that, with the amplifier still in the cabinet or in the combo cabinet, if it's a Marshall JCM 900 combo, the average person can just try putting a patch cable and in and out of the effects loop and see if that improves their situation before you call or bring this to an amplifier tech. This is a newly completed M5.7 amplifier just waiting for its own cabinet. And we're going to use this as the power amplifier, and we are going to send the signal out from this Marshall JCM 900, and that will mute the power amp, and it will also let us use the preamp in this amplifier to see if the preamp section functions properly. If it does, then we know that the power amp section is the problem. If we wanted to, in reverse, just check the power amp, we could insert a signal here into the return and use something like one of my overdrive pedals as the preamp, and then we can test the power amp independently. But we will see how far we get. I have a suspicion that there is actually something wrong with the power amp section and that the preamp may work properly, and this will tell us if my suspicion is correct. Okay, so the JCM 900 is on, the Mendito Amplification M5.7 is on, and they are linked together through the send on the effects loop. And it sounds like the preamp section here. Let's go to the dirty channel. Alright. It sounds like the preamp works just fine. So that would lead me to believe that we've got problems with the power amp section. So we're going to skip the next step of the process of plugging something into the return and using the power amp, and it's obviously something wrong with the power amp on the JCM 900. So the next thing that I'm going to do is I am going to check the electrical values on the output transformer, which is this guy over here, which I am not going to touch with my fingers because it is energized with high voltage. Remember, wooden stick, not conductive. You don't stick anything conductive into a high voltage guitar amplifier. So we're going to take apart this makeshift array, and we are going to unplug the amp. We are going to discharge the electrolytic capacitors so that we don't zap ourselves, and then we're going to look up the spec on the output transformer, and then we're going to start testing the DC resistance of the windings. Now we are going to discharge the electrolytic capacitors. So right now the amp is still on. It's on standby. We're going to shut it off. We're not going to stick our fingers down in there. That's got AC from the wall. Now we're going to unplug this IEC cable. Now, you would think that you're safe now, right? No, you're not. So we're going to take an alligator test lead, and you're going to clip it to ground, which is, here is a good chassis ground. And here I've got the other end on my chopstick. And then we're going to come over here. Whoop, see that? And there's another one down over here, just a little bit out of the shot. We're just going to check that one. Alright, that's discharged. So now you're safe, okay? You don't want that to discharge into you, because you will act as the ground, and then that will go into you. And if you are, there's always a rule that you want to keep your other hand that you're not working with in your pocket or off of the chassis. If you were to be touching the chassis or touching ground, that can travel across your chest and through your heart, and it could potentially stop your heart and kill you. So remember, wooden stick, discharge your capacitors. I can't stress that enough. It hurts. It's not cool, and it could kill you. So safety first. This is the most important thing that you need to know about working on a tube amplifier. Next step in our diagnosis, we are going to check the DC resistance on our output transformer. So this is the center tap. Let's not get into exactly what that means. That'll be the subject of another video. This one goes to the leftmost in this orientation power tube, to the plate or anode, and then this one goes to the plate or anode on the rightmost power tube, which in this circumstance, these are 5881 power tubes. This is a 5881 version, not the EL34. I believe that at the time that this was manufactured, there was actually a shortage in sourcing the EL34 tubes, so they went with 5881 tubes that were more plentiful. So we're going to put one lead here, okay, and then we're going to check the DC resistance. Now the spec said this should be around 40, okay, that is pretty close to 40. This one should also be 40 from center tap, and oh boy, well, that's like 320 something K right there. So I think this here is the problem. So we've already narrowed down the fact that the preamp section works properly and the power amp section sounds terrible. This is, I mean, we did all of the subjective proof by listening, but this is your objective, measurable, undeniable proof that, here you go. And I also believe that the resistance between these 2 points, this should be 80. And also, see that? So we are up at 300 something K again. So this output transformer is fried. Before anyone makes a comment, I would just like to address why I'm using such a cheap meter. When you forget to change your function, and you're working on something that's high voltage, and you go to test voltages, you're going to blow up your meter. You're either going to blow up that function, or the entire meter is just going to stop working. So with this one, I'll just throw it out and reorder a new one, as opposed to trying to repair an expensive meter or having to replace that. So in this circumstance, when you're not doing very fine, precise measurements, this is actually better. We have identified and ordered a new Hammond 1750P output transformer. We have our coffee, and now we are going to replace these 3 electrolytic capacitors. We have replaced one CAN capacitor. This one only gets attached on one side, one capacitor. Solder joints are nice and shiny. Time to move on to the other 2. I would just like to point out a variation on this particular 4500 circuit with the 5881 power tubes. And here you have two 500 volt 50 by 50 microfarad CAN capacitors. And on this one, they left this capacitor out. Whereas on other circuits, this capacitor is joined together to make a 100 microfarad capacitor. As I'm desoldering these leads on this CAN capacitor, I just want to point out that all they did was strip a tiny bit of wire, poke it through, and completely rely on the solder to do everything. And they can at least make it a little bit longer and just wrap it around a little bit, but that's not what they did. On older versions of the JCM 900, these capacitors were grounded directly to the chassis, but here we have them grounded to the center tap of the power transformer. On these older PCB amplifiers, I like to actually leave the leads from the old capacitor, and I'm not just going to be lazy and tag on with some solder the new capacitor. I'm actually going to make a nice mechanical connection, but instead of desoldering and risking damaging the traces on the board, I find that this is a better method. So like I said before, I left the existing lead from the old capacitor and I made a mechanical connection to it and soldered on the other side. I reflowed it gently here, and then here got a nice new solder joint on both sides with I wrapped it around and made a mechanical connection. Why would I do it like that? I don't trust these boards. So I didn't have to do any tiny little work on the op amps or any of the other components. So I'm not taking any chances. Our new electrolytic capacitors are all installed. So now we're going to have to take this off of the bench and wait until our new output transformer arrives. Our replacement output transformer has arrived. It is a Hammond Manufacturing 1750P. It's a direct drop-in replacement. Everything seems perfect. So now I have our schematic up on the screen, and the first thing that I want to do here is this resistor and capacitor is over here, tagged in. And I want to take these out of the circuit and test them to make sure that they are within specifications, because this output transformer has been burned out. So that's the first thing I'm going to do before I remove anything. I suggest before you remove anything is to make sure you take a photograph or draw a diagram so that you know where all these wires go, because looking at the schematic could be a little bit confusing later. So why not just take a photo or draw yourself a picture before you do anything else? Before anyone asks why I have a long nail on my pinky, my ring finger, and my middle finger, well, that's because I play a pick and fingers style technique. So I actually use my fingernails and the guitar pick when I play. The nylock nuts that mount the output transformer to the chassis are a little bit of an odd size. 11/32 or 9mm will work, but they're both a little bit loose. And 8mm and 5/16, they're just too small. The other problem here is that the bolts supplied with the Hammond output transformer are a little bit skinnier, and they don't give you a nylock locking nut. So I would suggest that you take the original bolts off of the original Drake output transformer and reuse those. Another thing worth noting is that there is the nylock nut, and then there's a metal washer, and then there's a fiber washer that insulates the bolt from the chassis. So you want to put those back in the proper order. I would suggest you have some slack here on all of these wires that go to the output transformer. So don't bother trying to desolder these and reuse the frayed up nasty ends. Just cut them as close as possible to these terminals and then strip them a little bit and then just use fresh wire ends instead of trying to desolder that. It's not worth it. Here is the replacement Hammond 1750P transformer on the left and the original Drake 784348 transformer on the right. They are pretty much identical. You'll see there's a little bit of a difference in the height, but that is really just that the bell on the Drake transformer is a little deeper. So I suppose if it made you feel better, you could put the bell from this transformer on this one, but I'm not going to do that. I'm going to install this Hammond transformer as it is and just reuse the original bolts. But everything looks really good. And I'm also going to just clean up this dust and nastiness a little bit before I continue. The new output transformer is in place. Just want you to remember that you want to put that fiber washer first, then the metal washer, and then your nylock nut. This quarter watt 56K resistor and this banded 10 nanofarad capacitor did not survive being removed and tested. So we are going to replace them with this 1 watt carbon film 56K resistor and this 400 volt 10 nanofarad capacitor here. The output transformer installation is complete, and so far physically it's a success. The 56K resistor and 10 nanofarad capacitor are installed on the 4 ohm tap and going out to this violet wire. Everything is soldered, the wires are strapped, so now I just need to check over and make sure there's nothing that I overlooked. I'm going to install the 5881 power tubes, and we're going to see if this output transformer works. I have installed the 5881 power tubes. I plugged in a speaker cabinet, I plugged in an instrument cable, and I turned the power on. But I saved the moment of truth for you guys. Let's see if this works. Got a hum. Seems to work properly. So now I'm going to plug in a guitar and we'll see if it actually really works and sounds okay. Before I plug in a guitar, I unplug the instrument cable so that the input is grounded to itself, and you get a little bit of hiss when you had the volume all the way up, but there's no hum. So I changed all these electrolytic capacitors, and the main one, the axial on the front board, and that seems to have also solved the problem with the hum, and it also could have been the bad output transformer. So I'm going to plug in a guitar and play it, but it seems like this amp is pretty rock solid, and this is going to be a nice piece for the rehearsal studio. Okay, we've got our Candy Apple Red 1991 Ibanez RG560, and we're plugging it in. Gonna turn up master volume a little bit. Put it clean on the neck pickup. works perfectly. Here is the amplifier reassembled with all of the knobs in place. Here is a view of the rear with the back panel installed. Unfortunately, we did not get a chance to record a sound demonstration video. We were just too busy at the store, but they did bring me several new repair projects to use in future videos. Thank you for watching our video. Please come and visit us at our store in Bensonhurst, Brooklyn. Do you need help with an amplifier or instrument repair? Leave your comments below, give us a call, or write us an email. Check out my amplifiers and pedals at menditoamps.com. Please like this video and subscribe to the Mendito Amplification channel. We will have more videos for you very soon, recorded right here at the Mendito Amplification Annex of Maggio Music Center in Brooklyn, New York.